Hey, again. Let's finish up with this chapter 19, or work on it some more this morning. And about 15 minutes is all I can talk, supposedly, because if I do that, it's harder to upload it on YouTube. So I'll probably screw it up. But anyway, we're going to finish this up in a couple different sections right here. This will be for your quiz 7, I think, because quiz 6 will be the functions of the blood, chapter 19, down through the RH factor. And if you mess up on one, don't worry about it. If you don't start or stop at the right place, but are close, I'll be happy with that, okay? So let's go ahead and finish up with there's a chart in here about most of the least common types of blood, okay? I usually scratch this one, but you got time to look it up. On figure 19-7, by 651, you're probably 671 or somewhere in there. At the bottom of the page right here, difference in blood group distributions, okay? So I want you to, from that chart, give me the most common type of blood and include the RH factor. It's either RH positive or RH negative, all right? So tell me the most common type of blood and the least common type of blood worldwide, if you would please, all right? Now, I want to talk to you about neonatal erythroblastosis. And that's a hell of a term, ain't it? Neonatal erythroblastosis, all right? I'll write it up here, but I'll give you the facts involved in neonatal erythroblastosis. Let's take a look at the word just for a few seconds. Neonatal erythroblastosis. In the neonate, in the newborn, okay? A neonate's probably up to about a week old or something like that. So the baby is less than a week old right here. Erythroblast is a young red blood cell, no big deal right there. Erythroblast, E-H-R-E-O-R-T-H-R-O. I left out the T-H-R-O. All right, but the spelling's right there in front of you. Blastosis. So the neonate, the red blood cell in the baby is rupturing. Why would the red blood cell rupture? Okay, now that's what we want to take a look at. It's also called fetal erythroblastosis. Notice present in horses also. Okay. I just thought that's a tidbit, but anyway, it is. So this is an incompatible RH factor, an incompatible RH factor. Now, ladies, if you're RH positive, this does not pertain to you, except for this quiz. If you're RH negative, ladies, and you marry somebody that's RH positive, and you get pregnant by an RH positive male, this might be a problem. I say might be a problem, okay? It doesn't have to be. It can be prevented, all right? But let's take a look at this right here. So the female is RH negative, the male is RH positive, okay? The F1, the fetus, the F1 right here, is going to be RH positive, all right? So, ladies, if you're negative and the male is positive, the baby will be RH positive. So you're carrying a baby with a different type of blood than what you have right here. No big deal, no harm, no foul, not yet, okay? Now, during the pregnancy, during gestation right here, the blood cells from the baby will leak into your bloodstream, leak into the maternal bloodstream, and the mother will make antibodies against the RH positive antibodies that it's not familiar with, okay? So the steps are RH negative mother, RH positive father, F1 RH positive, right? So the baby is RH positive right here. The mother makes antibodies versus RH positive baby cells. The mother makes antibodies versus the RH positive cells, okay? Now, no big deal, no harm, no foul, not yet. These antibodies are stored in the colostrum. That's the first milk. The antibodies are stored in the colostrum. Step, 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 antibodies stored in colostrum. All right? Now, the mother has her baby. Now, it's a very conscientious mother, like you all will be. You want to do the best thing for your baby. You want to give the best head start that you can, so you breastfeed. You feed the baby the antibodies that that you have produced during the year of during the 9 months of pregnancy right there. Your body makes antibodies against any antigen that you have been exposed to. It is stored in the first milk called the colostrum. So, the baby nurses. Baby nurses. in your RHCS. The baby nurses right there. Now here's the problem. The baby ingests antibodies against its own red blood cells. So the erythrocytes, the red blood cells, lyse, and the baby dies. This could have a sad ending, it really could. So the baby nurses right here, baby's red blood cells, lyse, and the baby dies. Now this can be prevented. It can be prevented with a shot. Ladies, if you're Rh negative, you can take a shot during pregnancy that will prevent your body from making antibodies against the Rh positive baby cells, all right, the red blood cells in your baby, in your neonate, in the fetus, okay? So this is neonatal erythroblastosis right here. Don't worry about listing the two causes. Tell me the prevention, and then look it up. Look up neonatal erythroblastosis, and there's a shot that you can take. But again, if you're Rh positive, ladies, it doesn't matter, except for this instance right here. Okay, let's go on here. Now I'm not worried about granulocytes and agranulocytes as far as the white blood cells, okay? So you can scratch that one right there. Some of them have granules, some of them don't. No big deal. No big deal if they have granules or if they don't, okay? So that's not an important fact anymore. So you go ahead and scratch that one. Characteristics common to leukocytes. Now, from the page of the blood types that we have right here, excuse me a few seconds right here. Yeah, dadgummit, I don't know where they are. Oh yeah, the first pregnancy, the second pregnancy, the combination of the pages of the neohemolytic disease of the newborn. It's another term for it right there. Figure 19-9. Right prior to that, we have circulation and movement of the white blood cells. Characteristic traits of the white blood cells. We have 4 listed. So instead of 3, I want 4 of them right here. Amoeboid movement right there, attracted to specific chemical stimuli. They migrate out of the bloodstream. Okay, no big deal. We know some about that. So just list 4 characteristics of the white blood cells. That will suffice for this one right here. Now, assign, let's name the leukocytes. Leukocytes being the white blood cells. Let's go ahead and name them again and assign a function to them. We have done this before. This is kind of a review. Right, no big deal on this right here. All right. I'll probably step to the side when I write so to give you a chance to write it down, all right? I apologize for that. Okay, now it doesn't matter which is most important, most abundant or not, but I'll probably take them most abundant to the least abundant, just for the heck of it right here. The neutrophils are the most abundant, neutrophils. Bacterial phagocytosis, phagocytize, engulf bacteria. All right. Not so much viruses, but they're really good for phagocytizing bacteria on the neutrophils right here. That's around 60%, okay? 50 to 60, 65, somewhere there. So I'm gonna put down 60%, just for the heck of it right here. Around 60% of all of our white blood cells, all of our leukocytes, are neutrophils. Lymphocytes are the next most abundant. Immunity is its function. So somewhere around 35% of the remaining 40% of the numbers are right here of the white blood cells are lymphocytes. Now the rest of the other 3 right here don't really matter as far as the percentage wise right here. We've got basophils, we've got eosinophils, we've got monocytes. So it doesn't really matter how you list those right there, but they make up about 5%, a total of about 5% of the remaining numbers of white blood cells, right? So I'll just list some basophils. Now, basophils are in circulation. Their counterpart in the tissue is a mast cell. They have granules, histamine and heparin, okay? Histamine and heparin are the granules that the basophils contain. So that's what I want you to write down. Histamine and heparin. Huh? Eosinophils, eos, E-O-apostrophe-S, eosinophils right there. Very, what they do, they fight off allergies and parasites. Allergies and parasites, that's what I want you to write down. It's evident there's a receptor site on the allergy, a receptor site on the parasite that the eosinophil can attach to. And that's no big deal right there. I don't need that in your answer right there. Also that they respond to an allergic reaction and a parasitic infection. Allergies and parasites. And evidently, there's a problem in some people that have a persistent allergy, where you have an eosinophilia, an increase, and eosinophils, and there's medicine to block the reproduction or the production of the eosinophils. Because anytime that you get too many of these blooming things, you're going to have problems, right? It's just the way that things work right here. So we've got basophils, eosinophils, and the monocyte, Phagocytosis again. Right? The tissue cell for the monocyte is a macrophage. Just thought that's a tidbit right there. That's a tidbit. So that is the five types of leukocytes that sign a function each right here. Now I want to split this up in here just for a few seconds about the neutrophils. There's two classes of neutrophils, all right? And this is important. It really is. Not as important as coronavirus, of course, but it is important for us right now. So we'll take a look at the neutrophils. All right? Now this is based on maturity. Based on maturity, we have bands and we have segs. We have bands and we have segs. That's what I'm writing here. Two classes of neutrophils, all right? We have bands, B-E-N-D-S, and segs. Now what this refers to is the shape of the